Hello, welcome back to my channel. Today I want to talk about coding computer art using GLSL, writing shaders. And we're going to do that in the framework of THREE.js in a web browser. Let's get started right away. Here. There's not much to look at here, but this is a simple THREE.js scene, and I've got a polygon, a single plane, smashed up right against the camera, and I've applied a material to that polygon that's a shader material, and I've written a shader. Actually, this is code that I pulled right from shadertoy.com. This is the code. Let me make it a little bit bigger. Or a lot bigger. And that's about big enough, I think. Cool. Make this a little bit smaller. Just like that. Yeah. So let's talk about the setup here. This will all be available on GitHub in the repository linked in the description of this video below. What we have here is an HTML file, and that HTML file will import this main.js script. Okay? This main.js script is a very simple THREE.js scene. In fact, we don't need this stuff here. And this is the same boilerplate we use all the time. Actually, one slight difference is this use of an orthographic camera instead of the perspective camera that we usually use. I've got an asynchronous function. Okay, this is called right from the get-go, and it's asynchronous because I want to use the wait keyword when I fetch the vertex shader and the fragment shader. All right, so we're almost there. HTML file loads a JavaScript file. That JavaScript file fetches two shader files, a vertex shader and a fragment shader. Vertex shader is just boilerplate. We're not really going to mess with that at all. We're going to leave that as is. The fragment shader is where we'll focus our attention, where we'll write the code for our shader. A little bit more about the setup here. For THREE.js to know what you want from a shader material, it's going to need a few things. It's going to need the vertex shader and that fragment shader we discussed. And it's also going to need uniforms. In the terminology of GLSL in OpenGL Shading Language, uniforms are values that you pass to the GPU that are the same for every pixel. In this case, we're giving a value for time and also for the resolution of the window. And we're setting that we're updating the time value each time, and we're also updating the resolution value, which doesn't really change much. In fact, it doesn't change unless I resize the window, and then it changes. But it's nice if it changes. Let's jump right into the shader. Let's talk about what's going on here, and let's talk about what the code is written into. It's written in GLSL. GLSL is a shading language created for parallel programs. They're run for each pixel of the screen. It's not exactly precise to say it's each pixel. It's actually each fragment. But a fragment is analogous to a pixel. So we'll just say a pixel. There are global variables here which the GPU needs. And one of them is the GL_frag coord, which is the fragment coordinate or the pixel coordinate. And the other one is the frag color or the pixel color. This has to be in your program. This is the output. Here, I'm going to say vec3, and I'm going to say, let's make it red. Now my color is red. Great. What's happening in these three lines of code right here? by the way, in addition to this needing to be in every program, this GL frag color, every program must have a main function as well. The void indicates the return type of the function, which is to say no return type at all. As are these keywords here, the vec2, vec3, and float. These indicate the types of the variables. You can also use that keyword to cast a variable. So in this case, I'm taking the color, which is a vec3, and another float, 1.0, and making that into a vec4, because that's what GL frag color wants. It wants a vec4. Good. Here, I'm taking, let's see, I'm getting this st variable. And that gives us a kind of specific coordinate to work with. If I wanted to, I could say st times equals 5.0, and now I should have 5 times that image is reduced to 1/5 and displayed 5 times. So let's say 15, and now we'll see a bunch of them. 150? How about 150? Okay. Or just 1. Good. And if I were to make this an integer and save it, I think it's going to explode. That's because GLSL is pretty unforgiving and very specific about floats and integers. Okay. And here it's saying you can't give it an int to a value that needs to be a float, and that's easily to fix by just making that a float instead. Great. Let's save this. To do something interesting, why don't we make a circle? Here's how I think we can do that. I'm actually not 100% sure. Let's see. Float dist is equal to length st comma vec2 0.5. So that's the distance, and let's see, comment out this one, actually leave it uncommented, and say, hold on a second, color equals vec3 dist. Let's see if I've got a circle. I do not see a circle. Is there an error? There is indeed an error. Dist is length, and that's because length wants a value that's not a vec2, I guess. What about distance? What about that one? Yeah, that one works. Times 2.0 to make it a little more contrasty. So it's 4. Okay. See how it's kind of squashed? Let's resize the window. Also, let's crisp up that circle. Right now it's a pretty fuzzy gradient, but if I say dist equals step 0.5, that represents the radius, and dist. Let's make it a nice crisp circle. It's actually kind of an oval because of the shape of my window. So we can fix that. Let's see if I remember how to do that. I think it's st dot x. I'm just trying to remember this off the top of my dome. Divide equals resolution. Whoops. Dot y. I'm not sure if that's right. I don't think that's right. Is it mad? It's not mad, it's just not displaying anything. Is it times equals? It's not times equals. Let's figure it out real quick. The st.x times equals resolution.x divided by resolution.y. So let's do that. st.x times equals resolution.x divided by resolution.y. Good. That makes our circle stay round no matter how big the window is. And because I want my window to be a little bit smaller, I'm just going to scooch this over a little bit. That's the X coordinate, make that 2.5, and this 5. That's a little bit too much. So is that. Cool. Let's combine, as a last thing today, let's combine the color with that shape. We'll do that. This is how I want to do it. I'm going to call this a hue, and then call this vec3 color. That still doesn't break anything. Everything's working as expected. What if I said times hue? Now the color's all around that black circle. How do I do this again? Color 1.0 minus dist. So that inverts that. Everything that was black is white, and everything that was white is black. Just so you see that. I'm just inverting the color and then multiplying it by that hue to get that circle. That's it. That's my lightning overview of GLSL shader programming with THREE.js. Please leave a comment below if there's something you'd like to see me work on, or any questions you have. I'd love to hear them. Thanks so much. Bye, everyone.